All right, so right now for this video, we are going to do more drawing file practice for these. The key is that this backside offers the challenge of arcs and circles, which are dimensioned by their radius or diameter, depending on whether it's an arc or a circle, and its center point. Okay, size and location is the key, and it actually gets kind of tricky, especially with the ones with all these different holes. We're actually going to use, if you recall from the mini train drawing files where it had TYP, which means typical, which means it's the same at a bunch of places. But these first 8 actually don't have any curves. So we are going to fly through these. We might be able to get through all 8 of these on this video, depending on how fast it goes. But just like with the letters, we are going to have one drawing file. So we need to go new, the shortcut default dropdown for drawing file. And we're going to have a different sheet for each part. And so for this first one, let's go ahead and edit the name. That's the first thing you should do. And you could either do 1 as the name of the sheet, or just because the numbers are going to get kind of redundant or confusing. For this, I would go part 1, and whichever choice you do, I would say critical, just be consistent. Be consistent. So let's go ahead and do a base view. And I can't remember for this class if I showed you or not. Can't remember if it's a default setting or if it's something I changed, but all I've done right away is just base view, choose part 1, hit open, and it will give you one. And before I was telling you to hit OK and then do projected view, but you can see that I haven't clicked anything yet, but it's already given me the box for a projected view. And I can click there and click over here and then click up here and do right click OK. And I get to skip the step of creating a projected view, which, to be fair, is only a few seconds saving, but why not? And for this series, I definitely am going to do turn on shaded, which is something I could have done before I clicked OK. And go like that. And so now let's get to dimensioning. Same process, left to right. Every time something happens, take a dimension. And I am going to redo things with smaller versions of the same part so that you can actually see what dimensions I'm putting on there and where I'm clicking. I think 1/4 scale worked for that. And we'll go like this. And the projected views all work the same for this, but it doesn't really matter for you because you guys are doing full scale. And let's go like that. And if anyone can figure out a way to change the size of the text, it's in there somewhere. There's some sort of edit style, something. I'm always concerned or aware of the fact that Inventor is different because it's on these machines that you don't have admin rights to, and there's a lot of settings that you can't change, but you should be able to edit the text style or something like that. Either way, we have our 4 views. Okay, we're going to annotate and dimension and width, left to right. First thing that happens is the top of this. Okay, This isn't to a contour. This isn't the edge of the shape. This is the edge of the shape. But there's not really anything better, so we'll just go there. The second thing that happens is where the end of this first slope face happens. But here we have an extension line on the view. That's not ideal. We're definitely going to go to the top view. Not only does the extension line not cross onto the view up here, it goes to a contour, which that's the dream. So we'll leave it like that. And then we'll go back. Next thing that happens is the distance from the left side to this vertex, this corner. And the front view is everything we're looking for, contour and whatnot. And the only other width is total width, which total width, height, or depth can go anywhere. It's always going to go to a contour as long as it doesn't cross other extension lines. Okay, so that's width left to right. Height down to up. There's only one height dimension, and that's it. We could put it here on the front view, which would have been fine if this total width was on the top view. But we can't because it's on the extension lines cross as is, and that's it. Then depth front to back, and the choice here is clear. Even though you wouldn't need to cross over anything on the right side if we put our dimension lines here, here, and so on, because we definitely want them on the top because this is the contour of the shape. It's the edge of the shape. These dimension lines are internal lines which don't add any information. So our depth lines are all going to be on the top view. From the front to the back, the first thing is from here to here, which we could put over here or sort of like, not that, but internally. I don't know why it's not giving me that. Anyway, that works. Same thing, front to back there. And total depth could go either, but if I have the other two depth dimensions there, I'd probably want them next to each other. And that is part one. I'm going to go ahead and make sure I save my green sheet numbers. Okay. Make sure you're giving your files meaningful and descriptive names. It will auto-populate the file name in the text box in one of the text boxes over here. If you're still wrapping up your letters, don't change the file name by going into your Finder window and edit file name or whatever. That will break it. The only way to change a file name of an Inventor file is to do File, Save As. Until you start getting into sort of more advanced file types and applications and other things than Microsoft Word, which I guess you guys don't even use Microsoft Office anymore. Regardless, you're going to get used to doing Save File, Save As. Save As makes a copy, even though there's Save As a copy. It makes another file exactly the same, at least the same at the time that you hit Save As, but you make a different name of it. Okay, it's a good way to do version management and organization and that sort of thing, but it's different than going into your Finder, your Explorer window, and actually changing the file name. If you do that, if you go into the file name and change it, it will break it. Don't do that. And okay, so there's part one, new sheet. First, let's edit the sheet name, and this is called part two. And it's going to get kind of confusing because the sheets are going to be 1, 2, whatever. And so let's go in here. We'll do part two. I'll do mine small again. And we'll go up here, here, and here. I click OK. Okay, this one, a couple different, we'll call them opportunities. Okay, starting left to right, first thing that happens is this sort of change right here. on yours, you will probably have room to fit the numerals in between the extension lines, but I'm super zoomed in and I don't. That's fine. Here it's fine. It's not to a contour. It's not to an edge of a shape. It's an internal line. But our only other option that comes in anywhere close is up here, which is the same thing. This is also an internal line. Not ideal, but it's fine. Next thing, going left to right, is this edge right here, which is perfect. It is a contour. That's the edge of the shape. It's between adjacent views. It's everything we're looking for. Then next thing that happens left to right, same thing. This is a contour of the shape, even though I would say on this one, the top view gives you a better idea of what's going on as opposed to this. This is still the contour of the shape. And that's the dream. So then the only other width is total width. And why not just stack it with the rest of them? Okay, all right, so height down to up. None of the options here are that awesome. First thing that happens is the height of, there's only two height dimensions. There's the height of this sort of ledge and the total height. So we don't like going to hidden lines, and we prefer having lines cross into the extension line, or extension lines cross over to the view rather than go to a hidden line. But it's not like this is that fantastic either. This is not going to the contour, and it's outside of adjacent views. But I suppose if we just stick with our hidden lines are bad, or dimensioning the hidden lines are bad, that's probably better. And the only other height is total height. There we go. And depth front to back. First thing that happens is this, which is the same thing as this. And even though these are both internal lines, they're not to the contour. I think that the top view does a better job of explaining what's happening. At 3 inches from the front is the end of this thing. And actually, if you think about, if you're trying to communicate the best way to build something, you might have this here instead of this one, but we don't really need to overthink things. The only other depth dimension is total depth, which, yeah, there you go. No dimensioning on isometrics. And save it. Anytime you see this, do yes to all, hit OK. And there you go. There's part 2. Place view, new sheet, edit sheet. Part 3. Base view. Part 3. And let's go ahead. We can just go ahead before we click OK. Just do the projected views. Right click OK. And so this one has some slope lines. I mean, we've had those before. The easiest way, without even checking the different, hold on, before I see a couple people misunderstanding. If you are, guys, take a look at this. Your drawings should not look like this. Full scale, like this. Okay. The only reason I was doing small is so that you can see the actual dimensions, because if I was doing it like this on the screen, you can't see what the actual numbers are, but I made it a smaller scale so that my dimension lines are bigger relatively. Okay, so if you have the thing you're about to hand in like this, all you need to do is right click on the front view, do edit view, and change your scale from 1/4 to 1, or 1/4 to 1.0. And actually, this is a bit of a disaster. You can, I would say, okay, take that back. All right, if this is what you have, I'm only doing this because I see at least two people with this situation. And this is a throwback if you're trying to keep up with numbers that we're about to do. Stick tight, hold tight. So I would say if you're trying to convert these back to the way they should be, spread them way out to where you want them on the sheet. Then on the front view, on front view, right click, not on a line, somewhere in like space. Right click, edit view, change the scale to 1, hit OK. And you have to do the same thing for the dependence doesn't carry over to the isometric view. No, that's not what I meant to do. Edit view, but change this to 1. Okay, make sure that the work you're doing looks like this, full scale and whatnot, and also, why not, shaded is good. All right, so back to my instructions. Okay, so this is part, where are we? Part 3, I've already named the sheet. And we're working through left to right. Every time something happens, take a dimension. So like I said, anytime there's a slope line and someone tries to throw us an angled, not an angled dimension like that, that's an angle. But anytime someone tries to throw a slope dimension on there, I know that they don't know what's going on and they're just guessing. So think about the way we made this. When we made this, and in fact, I don't think any of the green sheet parts, front or back, required a slope dimension. Everything was dimensioning verticals and horizontals based on what we know. Either way, left to right, every time something happens, take dimension. We go back to the left. The next thing that happens is this location here, which this is a little awkward. It's fine. If I was being sincere, I would say that it's probably better to put that dimension here, even though it's not stacked, but you can't have both of this one and this one because that's redundant, because we're going to have total width, and total width with this one lets you infer this one, and same thing the other way. Total width in this one lets you infer this one. The key is you're dimensioning the location of this point here based on one side or the other. But just to avoid confusion, let's just stick with our left to right every time something happens. Take a dimension. Okay, so only 3 things happen. And there you go. Down to up, first thing that happens is this ledge. Here we go, contour between adjacent views, no hidden line. Beautiful. And the only other height is total height, which we definitely don't want it here. It's crossing multiple extension lines and it's super long. We don't like that. Let's just put it on the right side view. Perfect. And depth front to back. This is fine. It's an internal line, but that's fine. The other option is here, which is the same, not ideal, except this one also crosses onto the view. We don't like that. And the only other depth is total depth. Okie dokie. Okay, save it, Control S, yes to all, hit OK. And new sheet. You can see how once you start doing a few of these, it's pretty fast. This is part 4. Make sure you name your sheets. Do I not have part 4? Holy moly, I need to make part 4. Let's see here. Part 4 looks like this. Did we never make? Hold on, did we not make all of the letters? I mean, all of the numbers in class? Is anybody with us? I think we must have. I just probably saved it somewhere else. If we didn't, there is still those handout folders I can help you figure it out. But let me just make part 4 real quick. So you've got a box 5 by 3, 2, 5 by 8 by 5. So we'll start with a rectangle, 8 wide, 5 tall. Finish sketch, extrude 5. And let's cut away what we don't want. We've got a couple 3 by 3 sort of push down surfaces. And those are towards the front. So this is a 3 by 3. This is a 3 by 3. Finish sketch, extrude, choose this, switch it to cut. And the distance we want to cut, we only cut down 3. Then there's the slope face here and slope face there. Let's go put a sketch here in this line. We can just connect this point to this point, which we get snaps. Well, it's been a long time since we said that. Make sure you choose that, switch to cut and cut. Through all is fine, or any number bigger. 3 was fine. There's that. And then over here, another cutaway that goes from this corner to the top. It doesn't snap at the top center. It, the location of this, and if you already have this, I guess you don't really need to watch me do it. But since this is 3, and this is only 1, that means this point right here is not the top center of the remainder. It's only 1 from the left. So make sure you don't snap it. Or rather 1 from the left of here. So dimension this to there. We want that to be 1. And finish sketch. Extrude, choose that, switch to cut, and 3 is fine. And let's save this part. 5, 6, 7. Is this the only one I'm missing? I hope I am. Okay, part 4 is now in existence. All right, so back to our drawing file base. Choose this part 4. And again, I'm sticking with the small ones. So like this, this. And I always forget to do shaded. Let's just go ahead and make that policy. Just when you're making the base view and the projected views, turn shaded on. And let's do some annotations. Okay, left to right. First thing that happens is this point right there, fine. Or it's to an internal, it's not to a contour, but whatever. Same thing up here. Next thing that happens is this right here. And next thing happens is that. And the only other thing is total width. And there you go. Let me rearrange some of this. Give some more space as needed. This is so nice to be able to do this digitally. When we were doing this on paper, you can see how this is going to have a ton of, I mean, this one only has 4. There's some with like 6 width dimensions. And in order to fit them all in there stacked, you need to make sure that you have this the right distance away, which means that if you're doing it on paper, you may have had to erase it and redo it, but we just get to go like this. Boom, super easy. Okay, height-wise, first thing that happens is this edge right here. Good. And the only other thing is total height, but I know if I put it on the front view, it's going to cross over. So I'll just go ahead and do that here. Not like that, not like this. And there you go. And then, so that's height down to up, depth front to back. First thing that happens is the distance from the front to there, which I could put over on the right side view, but it would cross over this extension line. And the only other depth is total depth. Save it. And do I not get a yes to all? Okay, fine. All right, so for part 5 is a little different. because I want you to change the front view. The default front view for this is this right side. I mean, it's the side of the, well, it looks like this. I think a much more descriptive view of this particular part is this side right here. I think even though this has fewer contours, like the edge of this shape is only a rectangle. Here, the edge of the shape has all of these, let's just call it a house. It looks like a Monopoly house, whatever. Also, I'm gonna turn on shaded while I'm thinking about it. I still think if you wanted to show a single view that gave the best idea of what this was, it would be this. And that's just because the little Monopoly house is such a Monopoly house type of drawing, is such an iconic view, and not just from Monopoly, but a basic sketch of a house is so iconic that front view is probably better. Or excuse me, right side view works as a better front for our drawing. And that's the thing is, when you make your custom parts, the face called front may not be what anybody would consider the front. The faces on the view cube will correspond to your drawing file, whatever you put facing the XY plane or the XZ plane, whatever, will be called front, and everything else relative to it. But it doesn't really matter. It's like there's no up in space. It's, you just call it what you want to call it. But when you're communicating what it looks like, I think this is a better front, so to speak. And the projected works the same way. Top right, right click OK. And here we go. And I'm already thinking about how this is another odd shape, just because there aren't that many dimensions. I can already tell there are not that many dimensions that are going to go on the front view. And that's another lesson, is the best front view is usually going to have the most dimensions, because communicating the most information about what a shape is probably going to have the most dimensions, because you're dimensioning to that information. And so that could be an argument against everything I just said for the last 2.5 minutes. But we'll just work forward with this. Like I said, it really doesn't matter overall, as long as you're being neat and communicating all information. These are just sort of preferences and leanings. Either way. Okay, so left side, first thing that happens is this edge right here, but you can already tell this extension line is crossing over, and it's an internal line. And our other option is here on the top view, which goes to a contour. It doesn't cross over anything. You know, it's the dream, like I said. The next thing that happens is the distance from the left to the peak of this sort of front door situation, which is fine, except technically this does cross over onto the view. And up here, it's the same trade-offs, except doesn't cross onto the view. So we'll stick with that. And again, you're starting to see how this is working out, not ideally. But I mean, not ideal is relative, it's fine. Then left to right, it's the same thing as our first one, which is going to here. There's more contour. And the only other width dimension is total width, which I'm going to put down here just because that has a shorter extension view, and that's good. Okay, height down to up. First thing that happens is this ledge right here, or this edge or corner or whatever, which offers the same trade-offs as right side view. Okay, this is an internal line. It's not a contour, doesn't cross over, which is good. But yeah, that's fine. The next height is the height of this sort of front door push out. And right side view is better, doesn't cross over extension lines, and it goes to a contour, which is great. And the only other height is total height, which I absolutely would say here on the front view, as opposed to here on the top view, because even though they both go to a contour, neither crosses over anything. And that's good. This long extension line is just sort of unnecessary. And as far as trade-offs go, shorter extension lines are better. And then depth front to back. First thing that happens is the distance from the front to, or at least how far out the push out goes, which on the top view, our only options are top view or right side view for depth dimensions. There you go. The next thing that happens is the distance to the edge of this, which actually, now that I think about it, it didn't really, when we made this, we didn't need this 4 1/4 dimension. It just sort of happened. If you recall how we made this, we made a plane or an extrusion out here and then just extruded it back until it met. But if we're following our rules, we do need that every time something happens. Next thing that happens is distance to this edge right here, but on the top view, this sort of roof peak thing is not a contour, but it is over here on the right side view. So that's a better place to put that depth. And the only other depth is total depth, which can go anywhere. Let's go like that. There you go, part 5, which I didn't rename the sheet yet. Let's go ahead and do that. And let's do another sheet. Base view. 6, 7, 8, 9, 10, 11, 12. I'm missing 13. I'm missing 13 also. We'll do that one later. Okay, part 6. Let's go like this, and this. And let's edit the sheet. And let's fly through this left to right. First thing that happens is where this top face slopes down. There you go. Next thing that happens is the edge of this, which is the same thing as this line here. And, you know, if we are fine tuning, optimizing, min-maxing, the shorter extension lines are slightly better, but whatever on that trade-off. And the only other width is total width, which again, I tend to default to the front view, but the total width up here has shorter extension lines, which I guess is better. Okay, and height down to up. First thing that happens is the height of this ledge, which could go here or here. Again, about the same, shorter extension lines, maybe better. And the only other height is total height, which, yeah, they're both pretty good. Okay, depth front to back. First thing that happens is the distance from the front to distance to this back ledge, which this crosses over, not ideal. Let's put it over here instead. And the only other depth is total depth, which can go anywhere else. Let's put it right there. And save. And in case you're wondering, I don't expect you to keep up with this at full pace, which is why we're doing the video so that you can pause it and go back. But it does mean I expect you to do it correctly and completely, so know that. And let's go to part 7. And edit the sheet and change the name. Part 7. Let's go ahead and. Okay, this one's kind of, I think it was by far the trickiest one to make. but it shouldn't be hard to dimension because we have our, I didn't do projected. We have our rules, our mantra, our step-by-step guide to everything. And so left to right, first thing that happens is where this slope face starts, and it's about the same top or bottom. Neither is a contour, neither is an edge of the view, or yeah, an edge of the shape, which is not ideal, but neither goes to a hidden line or crosses over, so they're about the same. Next thing that happens is the distance to where this slope line goes to, which is absolutely better on the front view. Goes to a contour, doesn't cross over. We'd have to put it outside or crossing over if we want to do it there, which is not good. Next thing is distance from the left side to the center, which on the front view does go to a contour. On the top view, that's not a contour. That's just the center of the shape. And left to right, next thing that happens is from here to here. Good again. Then next thing that happens is this one. Same, this is, I mean, it's symmetrical. It's offering the same pluses and minuses on both sides. And it's starting to get kind of crowded. And this would have been a example of a part where if you're doing it on paper, you probably would need to redraw some things to have enough room, but we are lucky. And the only other width is total width, which even though this is a long extension line, I do like the stacked dimension look. Okay, height down to up. First thing that happens is the height of this bottom part of the V there, which this is crossing over extension lines. Not, I mean, the extension line is crossing over the view, which is not ideal, but on the other side, it's going to a hidden line, which is worse. Not which is worse, the question. That is worse, going to an extension line. And I think for the most part, just following these walkthroughs that I'm giving you are, you'll just get enough terminology to understand which is best. But if you forget, I have my hierarchy of dimensioning sins, which I'll show you where to get it from the spreadsheet calendar underneath dimensioning documents. There's dimensioning sins, so to speak, in quotes. And if it opens, it will have our list of trade-offs in order of worst to less worse. And so hidden line, dimensioning a hidden line is worse than extension lines crossing over view, which is our trade-off here. So we're going to stick with this instead of, can I even get, oh yeah, I can't get a point there. So there's that, and same trade-offs for the next part of the V, which is from here to here. And the only other height is total height, which again is fine pretty much on any view because it's always going to go to a contour. How am I supposed to get? Let's go like this. And there, and there. That. Okay. And then depth front to back, there's only one depth dimension, and that's total depth. Okay, there is part 7. Yes to all. And we'll do one more on this recording. I know it's a lot, but again, videos. Okay, part 8 looks like this. And this one's going to be pretty simple too. We'll go place view, new sheet, rename it. Part 8. Okay, base view. Let's pick our part 8. And we'll turn on shaded is still on. And we'll go top right. And like I said before, we never needed a slope dimension to do any of these drawings or part files, so we won't need them here. Okay, so let's start left to right. First thing that happens is this, which crossing over extension lines, not good. We'll go up here, and this is ideal. Goes to a contour and everything else. And the only other width dimension is total width. Simple. Okay, height dimension. First thing that happens is from the bottom to this front part here, which I guess I can probably get these closer, so you can actually see everything. Plus, this doesn't have very much dimensioning on it. And so if we follow our dimensions, this giving us a dimension of 4.4 is a hint that we don't actually need this dimension. Because the way we made this is we made the block, cut off the long slope, and then just cut back the distance along here and cut it back. But we're going to stick with our policy of every time something happens, just to avoid confusion. And then the only other height is total height. There you go. Okay, depth, front to back. First thing that happens is from the front to the edge here, and that should be 3. And then the only other depth is total depth, which is this. And just to make sure everything's the same, this should also be 3. Yeah. Okay, so that's the same thing. And there you go. And if we open up this actual drawing, or the actual part, if you're in a drawing file, you can do right click on the part or on the view and go to open, and it will open the part file. And here we can check if we have all of the dimensions, sort of. Okay, so this first extrusion was 8 by 6 and extruded however much. This process of going back and double checking and making sure you have everything, I don't know if it's the most efficient, which is why we are going to just follow our mantras of left to right every time something happens. But you can edges 3 inches in, yeah. Especially since a lot of the dimensioning for modeling the part is sort of the reciprocals of this. Like, for instance, this chamfer that we use to make the this front edge, which is like that, we dimensioned it 3 inches this way and 3 inches that way, and that's how we got this cutout. But we only have this dimension here. The difference is that this dimension of cutback 3 is, you're really just dimensioning the location at this point, and we are doing it from the left side. So yeah, the dream would be to go into the part file and see every one of your dimensions on the part on the drawing, because those are the only dimensions you need to make the part. So those are the only ones you need on the drawing. But there's a lot of inference needed to do that. So we're just going to stick like this. Okay, so there's part 1 through 8 in order. I'm going to save it and end this video there. And we'll pick up with the whole world of What time is it? Yeah, we'll start with the curved ones next time, which we can easily do in either 2 or 3 videos, which think about doing 9 and 10 right now, but 9 and 10 are great introductions for curved surfaces, either arcs or circles. And yeah, so that's where we will end it now. And let me know if you have any questions.